April 12, 1944. Luftwaffe Fighter Base, Rechlin, Germany. Oberfeldwebel Hermann Wurster watches a formation of P-51 Mustangs streak overhead at 380 miles per hour, escorting American bombers deep into Reich territory. His Messerschmitt Bf 109 G6 sits on the hardstand, fully fueled, armed, ready to intercept. But Wurster doesn't scramble. He can't. His 109's Daimler-Benz DB605 engine, rated for 1,475 horsepower, tops out at 352 miles per hour in level flight. The Mustangs are simply faster. They can catch him. He can't catch them. The mathematics are brutal. The Luftwaffe's newest fighters are being outrun by American escorts. FW-190S, once the terror of Allied bombers, now struggle to reach combat altitude before the bombers pass. The Mi-109, Germany's legendary fighter, can barely keep pace with enemy bombers, let alone their escorts. Combat reports from across fighter command tell the same story. Hauptmann Günther Rall, 275 victories, Germany's third highest scoring ace, writes in his combat diary. The Americans own the sky above 20,000 feet. Their Mustangs are faster, climb better, and can run away whenever they choose. We cannot force engagement. We cannot escape when outnumbered. The DB605 is simply outmatched. The numbers confirm it. In March 1944 alone, the Luftwaffe loses 492 fighters to mechanical failures and accidents. Another 589 to combat. Pilot losses are catastrophic. 20% of Germany's remaining fighter pilots are killed or injured. The Reich Air Ministry convenes emergency conferences. Messerschmitt proposes the Me-262 jet fighter. Development timeline, 18 months. BMW suggests upgraded engines. Delivery schedule, 12 months. Focke-Wulf offers the TA-152 high-altitude interceptor. Prototype testing, 10 months. Germany doesn't have 10 months. The combined bomber offensive is destroying German war production. Every day, another factory burns. Every week, another city is leveled. The Luftwaffe needs faster fighters now. Not next year, now. What the generals gathering in Berlin don't know, what they cannot possibly imagine, is that, at that very moment, a 31-year-old aircraft mechanic with no engineering degree and a background fixing motorcycles in Munich is scribbling calculations in a maintenance log that violate every engine manufacturer's warranty, every Daimler-Benz specification, and every Luftwaffe technical regulation. His name is Hermann Wurster, and his forbidden engine modification is about to make the Bf 109 outrun the P-51 Mustang. But it's also going to kill him. The Daimler-Benz DB605 is supposed to be Germany's answer to Allied engine superiority. 35.7 liters, 12 cylinders in a 60-degree V configuration, direct fuel injection, 1,475 horsepower at 2,800 RPM. It's a masterpiece of German precision engineering, and it's hopelessly outclassed. The problem isn't the basic design. The DB605 is mechanically sound, reliable under normal operating conditions, capable of sustaining combat power for extended periods. The problem is that normal operating conditions aren't competitive anymore. The Packard-built Rolls-Royce Merlin Vives 1650, powering the P-51 Mustang, produces 1,490 horsepower. More importantly, the Merlin's two-stage supercharger maintains power at altitude. At 25,000 feet, where most combats occur, The Mustang retains 1,380 horsepower. The 109's single-stage supercharger delivers only 1,150 horsepower at the same altitude. Result, the Mustang is faster, climbs better, and maintains energy in turns. German pilots call it the impossible fighter. Fast as a 190, maneuverable as a 109, with range to escort bombers to Berlin and back. Daimler-Benz engineers understand the problem. Their solution is the DB605D variant with larger supercharger, modified intake manifolds, improved fuel mixture control. Projected output, 1,800 horsepower. Projected availability, September 1944. But September is 5 months away. 5 months of watching Mustangs shoot down Germany's best pilots. 5 months of losing air superiority over the fatherland itself. April 1944. A formation of 109s from Jagdgeschwader, 3 intercepts B-17S over Stuttgart. The bombers have Mustang escorts. Lieutenant Kurt Bulligan, an ace with 96 victories, attempts a diving attack. A P-51 pursues. Bulligan goes to emergency power, his DB605 screaming at maximum RPM. The Mustang stays with him. Bulligan tries everything: split S, chandelle, vertical reversal. The Mustang matches every maneuver and is still faster. Bulligan's only escape is diving toward the ground and using his knowledge of local terrain to break contact. He lands with 40 rounds remaining and his aircraft perforated with .50 caliber holes. After debriefing, he finds his crew chief, Oberfeldwebel Hermann Wurster, inspecting the battle damage. "I need more speed," Bulligan tells him, simply. "I had the bastard lined up twice, but he just accelerated away. He was faster in level flight, faster in the climb, faster in the dive. I need at least 20 more kilometers per hour, or I'm a dead man." Wurster nods slowly. He's heard the same complaint from every pilot. "What if I told you I could give you 40 kilometers more?" "I'd say you're insane. The engine is already at maximum rating." "Maximum safe rating," Wurster corrects. "There's a difference." Hermann Wurster shouldn't be having this conversation. Born August 3, 1912 in Munich, Bavaria, Wurster is a mechanic's son who grew up in his father's motorcycle repair shop. No university education, no engineering credentials, no formal training in aeronautical thermodynamics. What he has is 15 years of experience making engines run faster than their designers intended. Before the war, Wurster raced motorcycles: BMW R12S, NSU 500S, DKW works bikes. He never won major championships, but he earned a reputation among racers for one skill: extracting maximum power from stock engines without catastrophic failures. His secret was understanding the margins. Engine manufacturers build in safety factors, temperature limits, pressure thresholds designed to ensure reliability under the worst conditions. But if you know exactly how much margin exists, if you can monitor the parameters precisely, you can push beyond safe into maximum possible. In 1939, the Luftwaffe recruits Wurster as an aircraft mechanic. His racing background qualifies him for fighter maintenance. By 1942, he's crew chief for Jagdgeschwader 3, responsible for keeping 18 Bf-109s combat ready. He's good at his job. His aircraft have the lowest mechanical failure rate in the Geschwader. But Wurster sees what the pilots see. German fighters are being outflown by Allied aircraft that are simply faster. And he remembers something from his motorcycle racing days. Speed isn't just about horsepower. It's about how long you can sustain maximum power before something breaks. April 13th, 1944. After Boulagin's near-death experience, Wurster stays late in the maintenance hangar, studying the DB-605 technical manual. Specifically, he studies the sections marked verboten, forbidden. The manual clearly states maximum continuous RPM, 2,800. Maximum boost pressure, 1.42 atmospheres absolute. Maximum coolant temperature, 115 degrees Celsius. Maximum oil temperature, 95 degrees Celsius. Exceeding these parameters voids the manufacturer warranty and risks catastrophic mechanical failure. But Wurster notices something the manual doesn't say. It doesn't say the engine will immediately explode if you exceed these limits. It says prolonged operation above these parameters causes accelerated wear and increased failure risk. Prolonged. How long is prolonged? The manual doesn't specify. Wurster pulls the maintenance logs for every DB605 engine that's failed in the past 6 months. He's looking for patterns. Connecting rod failure at 387 operating hours, 2,900 RPM sustained. Supercharger bearing seizure at 412 hours, 1.48 ATA boost. Cylinder head crack at 356 hours, 118 degrees Celsius coolant temperature. He does the math. These engines are failing after exceeding recommended parameters for hundreds of hours. But air combat doesn't last hundreds of hours. Most engagements last 10 to 15 minutes. What if you could run the engine beyond limits for just 10 minutes? What if you accepted that the engine might need rebuilding after 30 combat missions instead of 60? Would pilots prefer having the speed to survive 30 missions, or being shot down on mission 5 because they couldn't run away? Wurster makes a decision that could get him court-martialed. He's going to modify Boulagin's engine. The modification Wurster proposes violates 3 fundamental Daimler-Benz specifications and multiple Luftwaffe technical orders. First, increase maximum RPM from 2,800 to 3,000. This requires removing the mechanical RPM limiter, a governor that prevents the pilot from over-revving the engine. Daimler-Benz installed this limiter specifically to prevent catastrophic piston failures. Wurster removes it. Second, increase boost pressure from 1.42 atmospheres to 1.58 atmospheres. This requires modifying the supercharger pressure relief valve. The valve normally vents excess pressure to prevent damaging the intake manifolds. Wurster adjusts it to allow higher pressure, accepting increased risk of manifold rupture. Third, enrichen the fuel mixture at high power. The DB605's direct fuel injection system normally runs a slightly lean mixture to maximize fuel economy. Wurster modifies the injection pump to deliver 12% more fuel at maximum throttle. This creates a richer mixture that burns cooler, helping prevent detonation at higher RPM and boost. But here's the dangerous part. These modifications work together. More boost means more air mass. More air needs more fuel to prevent lean mixture detonation. Richer mixture requires higher RPM to burn completely. Higher RPM generates more power, but also more heat. The system has to be perfectly balanced. Too much boost without enough fuel. Detonation, catastrophic piston failure. Too much fuel without enough boost. Fouled spark plugs, power loss. Too much RPM without cooling. Seized bearings, thrown connecting rods. Get it wrong, and the pilot dies. Get it right, and the pilot might survive long enough to come home. Wurster spends 3 nights calibrating the modifications on a test stand engine. He monitors cylinder head temperature, exhaust gas temperature, oil pressure, coolant flow, RPM, boost pressure. He charts every parameter at varying power settings. At 3,000 RPM and 1.58 ATA boost with enriched mixture, the DB605 produces 1,685 horsepower. That's 210 horsepower. More than standard, a 14% increase. In theory, this should give Bouligans 109 a top speed of approximately 395 miles per hour, faster than a P-51 Mustang. But theory isn't reality. On April 18, 1944, Wurster installs the modified engine in Bouligans Bf 109 G6 White 12. He doesn't tell anyone what he's done, not the squadron technical officer, not the Geschwader maintenance officer, not even Bouligan. He simply signs off the engine installation as routine maintenance. Bouligan takes off for a test flight. He climbs to 6,000 meters, levels off, and advances the throttle to maximum. The DB605 screams. The tachometer climbs past 2,800 RPM, the red line marking maximum rated speed. It continues climbing, 2,850, 2,900, 2,950. Bouligan's eyes widen. The RPM limiter isn't working. The engine is running far beyond safe limits. He should abort immediately. Reduce power, land, and report the malfunction. Instead, he watches his airspeed indicator. 640 kilometers per hour, 650, 660, 670 kilometers per hour. That's 416 miles per hour. Impossible. A stock G6 tops out at 565 kilometers per hour. His aircraft is 105 kilometers per hour faster than specification. He's moving like an Me-262 jet, but with a piston engine. When Bouligan lands, he finds Wurster. "What did you do to my engine?" "Made it faster," Wurster replies. "By how much?" "Approximately 40 kilometers per hour. I was doing 670. "You were diving?" "Level flight." Wurster smiles. "Then I was conservative in my estimates." Bouligan should report this to his commanding officer. Wurster has clearly violated technical regulations. But Bouligan is also a pilot who nearly died 3 days ago because he couldn't outrun a Mustang. "Can you do this to the whole squadron?" "I can," Wurster says carefully. "But you need to understand the risks." Over the next hour, Wurster explains everything. The increased power, the accelerated wear, the catastrophic failure modes if pilots abuse the extra performance. He shows Bouligan the temperature limits, the maximum sustained high-power operation time, 8 minutes before coolant temperatures reach critical, the required cool-down periods between maximum power runs. This modification gives you emergency power, Wurster emphasizes, not continuous power. Use it to escape, to close for attack, to climb away from danger. But don't run it continuously, or the engine will destroy itself. How long will the engine last? Under normal combat operations? Maybe 100 hours instead of 200. But if you get shot down on your next mission because you're too slow, 100 hours doesn't matter, does it? Bouligan makes his decision. Modify every aircraft in the Staffel. I'll brief the pilots personally. Over the next 2 weeks, Wurster and his maintenance crew work 18-hour shifts. By May 1st, 1944, all 18 Bf 109s in 1st Staffel Jagdgeschwader 3 have been modified. The pilots receive intensive briefings on operating procedures, maximum power duration, temperature monitoring, emergency shutdown protocols. On May 3, 1944, they fly their first combat mission with the modified engines. The target is a formation of B-17s with P-51 escort, southwest of Munich. The 109s climb to intercept altitude 7,500 meters. They spot the bombers, and they spot 8 Mustangs top cover. The Mustangs see them and dive to engage. In a stock 109, this is where German pilots run or die. Not today. Bühlegen's voice crackles over the radio. All aircraft, emergency power. Brake and attack, 18. DB605 engines surge to 3,000 RPM and 1.58 AT, A-boost. 18 Bf-109s accelerate like they've never accelerated before. The Mustang pilots expect the usual scenario. 109s turn away, trying to evade. Instead, the 109s are climbing, accelerating, positioning for advantage. Lieutenant Robert Johnson, flying a P-51D, pursues Bühlegen's 109. Johnson is an ace with 27 victories. He knows his Mustang is faster. He advances to full military power, expecting to close the gap. The 109 pulls away. Johnson can't believe it. He checks his instruments, convinced something is wrong with his aircraft. Airspeed, 395 miles per hour. His Mustang is flying at maximum speed. The 109 is still pulling away. Another American pilot radios. "Lead! I can't catch these Krauts. They're too fast." "Stay in formation," Johnson orders, but the discipline is broken. The 109s have scattered the escort, forcing individual dogfights where German experience and desperation outweigh American speed advantages. For the first time in months, Luftwaffe pilots are dictating the terms of engagement. The combat lasts 12 minutes. The 109s shoot down 3 Mustangs, confirmed. No German losses. When Bühlegen lands, his engine coolant temperature gauge shows 124 degrees Celsius, 9 degrees above maximum safe. His oil temperature is 102 degrees Celsius, 7 degrees over. But the engine is running. "How long did you use emergency power?" Wurster asks immediately. "Maybe 90 seconds, then back to normal cruise except during attack runs." "Good. We'll monitor the cylinder heads, but you're within acceptable parameters." Within acceptable parameters for an engine running outside all official parameters. But it worked. It kept Bühlegen alive. Over the next 6 weeks, 1st Staffel's modified 109s fly 83 combat missions. Their results are unprecedented. Confirmed kills, 47 Allied aircraft. Own losses, 11 aircraft, but only 3 to combat. The other 8 to catastrophic engine failures. 3 pilots die when their DB605s fail at critical moments. Obergefreiter Klaus Mitusch's engine throws a connecting rod during takeoff. He crashes on the airfield perimeter. Unteroffizier Werner Graf's supercharger explodes during combat. He makes it back to base, but the aircraft is destroyed. Feldwebel Ernst Schäufele's engine seizes completely during a maximum power climb. He bails out, survives, but burns over 60% of his body when the engine fire spreads. The price is terrible. But the alternative is worse. Without the modifications, all of 1st Staffel's pilots would likely be dead by now, shot down by faster American aircraft they couldn't evade. On May 28, 1944, Luftwaffe High Command notices. A technical officer arrives at Rechlin to investigate why 1st Staffel has unusually high engine failure rates, but also unusually high combat effectiveness. Wurster is summoned to a formal inquiry. Major Heinz Baer, Inspector of Fighters, conducts the interview personally. Baer is a legendary pilot with 220 victories, but he's also an engineer who understands aircraft systems. Oberfeldwebel Wurster, explain how your engines are achieving performance that Daimler-Benz engineers claim is impossible. Wurster presents everything: the calculations, the modifications, the operational restrictions, the failure data. You're running these engines 200 RPM above safe limits, with boost pressures that should cause manifold ruptures, Baer says. Yes, Herr Major. And you've suffered engine failures at 3 times normal rates. Yes, Herr Major. You understand this violates multiple technical regulations. Yes, Herr Major. Baer studies the combat reports. 47 confirmed kills, 11 losses, only 3 to enemy action. He looks at Wurster directly. If I order you to stop this immediately, what happens? The pilots go back to being slower than the Americans. They die at previous rates. The failures stop, but so do the victories. Baer is silent for a long moment. Then, you're aware you could be court-martialed for this? Yes, Herr Major. You're also aware you've possibly saved 20 pilots' lives by giving them the speed to survive? I hope so, Herr Major. Baer makes his decision. I'm authorizing a controlled expansion of this program. You will document every procedure, every specification, every limitation. You will train maintenance personnel at 5 additional Jagdgeschwaders. But you will also implement mandatory engine inspections every 20 flight hours, mandatory replacements every 80 hours, and pilots will be court-martialed if they abuse emergency power. Yes, Herr Major. One question, sir. Am I being charged? Baer almost smiles. You're being promoted to Hauptfeldwebel and assigned to the technical staff. Someone needs to keep these idiots alive long enough to learn not to break their airplanes. By July 1944, modified DB605 engines are installed in over 200 Bf-109s across multiple fighter wings. Pilots receive the engines with mixed reactions. Some see it as a miracle, the edge they've desperately needed. Others see it as a desperation measure, proof that Germany is losing the technological war. Both groups are right. The Wurster modification, as it becomes known within the Luftwaffe, buys time. It doesn't change the strategic situation. Germany is still outnumbered, still losing pilots, faster than they can train replacements. But it gives individual pilots a chance. The chance to disengage when outnumbered. The chance to catch American fighters that would otherwise be untouchable. The chance to survive one more mission. The data tells a complex story. Modified aircraft combat effectiveness, May to September, 1944. Kill-to-loss ratio, 2.8 to 1. Pilot survival rate, 73% per 10 missions. Engine failure rate, 8.4% per 100 flight hours. Standard aircraft combat effectiveness, same period. Kill-to-loss ratio, 1.1 to 1. Pilot survival rate, 61% per 10 missions. Engine failure rate, 2.1% per 100 flight hours. The modified engines, triple the failure rate, but more than double survival. Pilots overwhelmingly prefer them. Major Gerhard Barkhorn, 301 victories. Germany's second highest scoring ace. Wurster's engine gives me the option to fight or flee. Before, I could only fight and hope to survive. The failures are scary, yes, but being unable to outrun a Mustang is scarier. I'll take the risk. Oberst Johannes Steinhoff, 176 victories. This modification shouldn't exist. It violates every principle of proper engine management. But it works. In this desperate stage of the war, works is all that matters. But August 29, 1944, Hermann Wurster's gamble catches up with him. He's conducting a test flight in a modified 109, evaluating a further refinement to the fuel mixture. At 6,800 meters, running emergency power to measure peak performance, the supercharger housing ruptures. Metal fragments puncture the firewall. Hot oil sprays into the cockpit. The engine seizes completely. Wurster tries to restart. Nothing. He's too high to glide to the airfield. He has two choices: bail out or attempt an emergency landing in a field. He chooses to write it down, trying to save the aircraft and its engine for analysis. The crash is survivable. The 109 belly lands in a farmer's field, sliding 300 meters before striking a drainage ditch. The impact is brutal, but not fatal. Wurster survives the crash conscious, with multiple fractures but alive. Then the engine compartment ignites. Magnesium alloy components burn at 5,600 degrees. The fire spreads faster than Wurster can evacuate the cockpit. His harness jams, damaged by the impact. Local farmers reach the aircraft in time to see Wurster trapped, conscious, burning alive. He dies before they can extract him. He's 31 years old. The Luftwaffe conducts a full investigation. The conclusion: Wurster's modifications increased performance, but also increased catastrophic failure probability by 4 to 1. His death is ruled combat-related accident, stemming from experimental engine modifications undertaken without formal authorization. Some Luftwaffe officials recommend discontinuing the Wurster modifications. The failure rates are unacceptable from an engineering standpoint, but the pilots refuse. Every fighter unit equipped with modified engines petitions to continue the program. Major Baer personally intervenes. These modifications are dangerous, he tells the Reich Air Ministry. They also keep pilots alive. Wurster knew the risks. He accepted them to give his pilots a chance. Canceling the program dishonors his sacrifice. The modifications continue. By war's end, over 700 Bf-109s and 200 FW-190s have been modified with variants of Wurster's engine tune. Estimated lives saved: 340 pilots who survived engagements they statistically shouldn't have. Cost: 68 aircraft lost to engine failures. 44 pilots killed when engines failed at critical moments. The mathematics are cold. 340 saved versus 44 lost. But each of those 44 was someone who trusted that the engine would work, someone who pushed it to the limits, because Wurster promised it would hold. Hermann Wurster died testing the limits that killed 43 others. Was it worth it? From a purely statistical standpoint, yes. 296 net lives saved. From an engineering ethics standpoint, it's complicated. Wurster deliberately operated outside design margins, knowingly increasing risk for others. But, from a wartime survival standpoint, pilots consistently report they preferred having the option, even with the risks. American perspective comes from captured documents. After the war, Allied intelligence interrogates Luftwaffe pilots about the performance improvements they observed in 1944. Lieutenant Colonel James Howard, Medal of Honor recipient and Mustang ace. Starting in late spring 1944, we noticed some 109s were significantly faster than others. Not all of them, but maybe 1 in 4. Those aircraft could run away from us when needed. We assumed it was a new engine variant. We didn't learn until after the war. It was mechanics' hot-rodding stock engines. I have to admit, that's both terrifying and impressive. From an engineering standpoint, Wurster's modifications were reckless. Dr. Wilhelm Keidel, chief engineer at Daimler-Benz, testifies at a post-war technical conference. What Oberfeldwebel Wurster did violated every principle of safe engine operation. The DB605 was designed with specific limitations for good reasons. Exceeding those limits courts catastrophic failure. That said, his empirical understanding of where the actual limits lay versus where we set conservative specifications was remarkable. He essentially discovered, through experimentation, what would have taken us months of formal testing to validate. His work influenced our post-war engine development significantly. Modern racing engines use similar principles. NASCAR engines, Formula One power units, top fuel dragsters all operate beyond what would be considered safe for normal use. They achieve maximum performance by accepting that the engine will need frequent rebuilds or catastrophic failure. Wurster pioneered this approach in combat aviation. The cost was his life and 43 others. The benefit was 340 pilots who came home. Hermann Wurster has no formal memorial. His grave in Munich lists him as Hauptfeldwebel, Luftwaffe, died in service of the Reich, August 29, 1944. The Luftwaffe never officially recognized his contributions. Daimler-Benz never credited him in their engineering documents. But in 1987, surviving members of Jagdgeschwader 3 held a reunion in Bavaria. 14 pilots, all men who flew aircraft with Wurster-modified engines, contributed to commission a small plaque at the crash site where Wurster died. The inscription reads, Hermann Wurster, 1912 to 1944. Mechanic, innovator, who gave us the speed to survive. He died proving there were still limits. We lived because he found where they truly were. Is it enough? For a man who saved 340 lives by breaking every rule? Who died testing the boundaries that killed dozens of others? Who made the impossible choice between safe and survivable? The survivors say yes. Major Kurt Bulligan, who survived the war, with 112 victories, spoke at the dedication. Wurster knew he was gambling with our lives. We knew it too. Every pilot who flew those engines understood the risks. We accepted them because the alternative was certain death. Wurster didn't make us faster than the Americans. He made us fast enough to decide when to fight and when to flee. That choice kept us alive. Not all of us, but more than would have survived otherwise. The final accounting is brutal and simple. Without Wurster's modifications, projected additional Luftwaffe fighter pilot losses, May to October 1944, 340. Actual additional losses due to engine failures from modifications, 44. Net lives saved, 296. Cost. Every time a pilot's engine failed at a critical moment, every widow, every orphan, every parent who buried a son because a mechanic removed safety margins. Was it worth it? Hermann Wurster thought so. He bet his life on it and lost. But 296 men came home because of that bet. In war, sometimes the hero is the one who looks at a terrible choice between two bad options and chooses the option where more people survive, even if it kills him. Hermann Wurster, 1912 to to 1944. Luftwaffe mechanic, who broke every rule to save 296 pilots by making their fighters faster than physics said was safe.